We use this piecewise notation to be able to describe lots of different graphs, not just absolute value graphs, but all sorts of graphs. And the piecewise functions, again, are just dependent on the defined function for a particular domain, and we have it in pieces here. Okay, so we're going to apply this function to this domain, this function to this domain. So to do this, we should kind of recognize what we have. We have a linear function with slope 2 here. We have a linear function of slope -1 here. And we're going to graph this portion for that domain. So again, I'm going to just make sure that I have some coordinates to work with. I know this is a straight line, so I don't need that many points. It's important to now start talking about, do we include the boundary or do we not include the boundary? Because we're going to have to draw this with these holes if they do not include the boundary, like here. And if it includes the boundary, we need to fill in that hole. So those endpoints are actually quite significant. So at -4, it's part of the boundary, so we're going to include that. We end up with x equals -8. So -4, -8. And that is part of the boundary, so I'm going to make that a solid. The other endpoint is going to be at x is 0, y is 0, and again that's going to be part of the boundary. It's equal to, so I fill that in. Okay, so there's my function. It's a slope 2x function from -4 to 0. Now after 0 all the way to infinity, we're going to have slope negative. And it's going to have a y-intercept of +4. So I'm going to start at 0, and that's equal to 4. Now, since it doesn't include that coordinate, I have to leave that open. And by doing that, it actually passes our function test. Okay? If we have overlapping parts, that it does not pass our function test. And this is going to be, I'm just going to draw out a couple coordinates here. So 4 is going to be 0. And so this is a linear function with slope -1. It's going to look like that. Okay, just going to